go. Okay, so this is vectors part 2. And first, can we turn off the lights? Then I can't see my nose. The mood is right. The mood is right. The mood is academic. So there's already enough people on this now. So what happened? Uh-oh, we're already messed up.
You done?
No, I didn't. I'm okay. So vectors continued. Is it going to be? There we go. Okay. So now I could write on top of this. I guess I should. Well, we're fine. So vectors continued. So the first thing they talk about is a unit vector, and we talked about this the other day, but it has a magnitude of 1. Okay. Magnitude of 1, and the way that you can find a unit vector, usually for unit vector, a lot of times they'll just use u, and they'll say u is a unit vector, and a unit vector is equal to any vector divided by its magnitude. Okay, so I'll give you an example in a second, which is equal to 1 over the magnitude divided times the vector itself. Okay? So for v, so for example, for v equals -1, 4, they'll say find the unit vector, find a unit vector in the same direction. Same direction as v, and verify that its magnitude is 1.
Mr. Larry?
Yes, sir.
Does U equal unit vector?
Yeah, in that case, the U stands for a unit vector. Magnitude is 1. Okay? So the way you would do that, you just take the vector itself and divide by its magnitude. So u in this case, we'll call u, is going to equal to is going to be the vector -1, -1 comma 4, -1, that's a comma, -1 comma 4. I'm going to divide it by its magnitude. Okay. Its magnitude is the square root of something. Square root of what? So it's equal to v over v magnitude, and that's going to be 1 squared plus 4 squared, the square root of it, right? Yep, you understand what I just did? Because that's the magnitude of vector v, right? And so it's going to be -1 comma 4 divided by the square root of 17. Yes? No? And you could write that as in a couple different ways, but how they want you to write it in component form is -1 over the square root of 17. Don't worry about rationalizing, okay? Comma 4 over the square root of 17, okay? In order to verify that its magnitude is 1, what I would have to do is take the square of the square root of those things, right? So to find the magnitude of any vector, I'm going to go -1. I take the square root of v1 squared plus v2 squared. So v1 is this, right? And v2 is this, 4 over square root of 17. And I'm going to square those and add them together and take the square root of it. Well, what's the square root of, what's 1 over the square root of 17 squared? 1 over 17. Just takes that box away. What's the square root of 4 over root of 17 squared? 16 over 17. What's 1/17 plus 16 seventeenths? 17 seventeenths. What's the square root of 17 seventeenths? 1. Okay? Right? So I just verified that the square root is equal to 1. You understand that? That is magnitude is equal to 1. Okay, so that's kind of one type of thing that you'll see. Then some more terminology here. I guess I'll just add a page here. Okay. Some more. Do you want me to go back? Anyone want me to go back? We're good. Yes. God bless you. And a pause. Pause. Oh, you can't see that. I have some word problems that are going to give you a headache in a recording and moving on. All right. So 1 0 and 0 1. 1 0 and 0 1. 0 1 are called, just so you know, are called the standard unit vectors. The standard unit vectors. And vectors. And another way to write 1 0 in another form, which they call linear, which we'll talk about that in a minute, is I. Okay? Any of you do this in physics? No? You call I the horizontal component, okay? And 0 1 they call J, okay? And if you go to 3 dimensions, guess what they call the other dimension? K. That's what happens when you take, like, calculus 2, you go into 3 dimensions and you talk the Hij vector. Okay? But in this case, actually we will talk about Hij vectors when we get to cross products. Okay? So if V is equal to V1 comma V2, another way to write this vector is just like this, V1I plus V2J. Okay? And that means I go so far in the I direction and so far in the J direction. So I is the horizontal component, J is the vertical component, and they call this linear combination form. And I can never keep which form is which. Like, this is called component form, this is called linear combination form when you have I's and J's. Okay? So so you might see something like this, and it doesn't mean imaginary number. It gets really confusing later in the chapter because I's go in the Y direction when you're talking about the imaginary plane. And you go, I thought I was in the X direction. So you got to be careful with that, but hopefully right now you're not confused yet. So if U equals 2I plus J, and V equals negative 3I plus 2J, could you do a problem where they say find 2U minus V? All you do is you add up the x's, or the x components and the y components. So 2U is going to be 2 times 2I plus J, and minus V minus negative 3I plus 2J, and so that makes distribute 4I plus 2J plus 3I minus 2J, and then you just kind of combine your like terms, right? So you have 4I plus 3I is 7I, and 2J minus 2J, that's it, right? No J's. No J's, so it's just plain old 7I. So what does that mean? If I take if I take two vectors that go over 2 and up 1. So let's just pretend these are them. Over 2 and up 1. There's another that's over 2 and up 1. And then if I subtract 1, that is back 3 and up 2, back 3 and up 2, back 3 and up 2. That would be the same as, and I subtract 1, that is back 3 and up 2. That would be the same as going forwards 2 and down, forwards 3 and down 2, right? Something like that. And so my resultant vector would be right here. I'm kind of, right?
Oh, so because it doesn't have the
Right, and since it's not going up or down, that's why this one is 7i. You see what that means? Because this is, here's 2i plus j, another 2i plus j, minus 3i plus 2j is actually adding the opposite of that. So that would be minus v, right, is equal to positive 3i minus 2j, right? So I go over 3 down 2, and my resultant is that I'm going straight across 7 without any ups or downs. See? And that's why the 7i vector. A j vector that's just j would go straight up or down. Yes? Questions about that? Okay then, let's party. No, we can't party yet. Can party like we're not allowed for direction angles. Okay? Can I move on? Can I move on, Ricardo?
Yep.
Okay, thank you. Direction angles. Direction angle is direction angle. It's the degrees counterclockwise from the positive x-axis. Okay, it's direction angle, and a lot of times they'll call it theta. Okay, it's equal to degrees, no radians, degrees counterclockwise from the positive x axis. Okay, and so using they call this, like, I'm not sure what they call this, but trigonometric form of a vector or something. But you can also write a vector as v is equal to the magnitude of v times cosine of the direction angle in the I direction plus the sine of the direction angle in the j direction. Have you seen this in physics? Anyone done this in physics? No? Not yet. Okay? So, so if they have a picture like this, so sometimes they have like a, here's this, whoops, I should put arrows on both ends, I guess it doesn't really matter, but this, and if you have some vector that's going up, okay, like this, okay, where this is 30 degrees, and this is, and this has a this has a length of, say, 50 going this way, okay, and they'll say something like, and this could represent like a ball being thrown at an angle of 30 degrees at 50 miles an hour or something like that. And they'll say, write the represent the vector in linear combination form. Linear combination form, okay? So you start off with this form, okay? And you get that v is equal to, well, if it's being thrown at 50 miles an hour, what's the magnitude of this vector? It's just plain old 50, right? And then theta is what? Theta is 30, okay? So cosine of 30 in the I direction plus sine of 30 in the J direction, right? And this is how they launch rockets and stuff like that. So they say V is equal to 50. Who knows what the cosine at 30 is? Root of 3 over 2 in the I direction plus, what's the sine of 30? Come on, 1/2, right? And in the J, whoops, it should be a J direction. And then I could simplify that a little bit by multiply through, and you get V is equal to 25 root of 3 in the I direction plus 25 in the J direction. You understand that? Okay? So if you were to throw a baseball or something like that at 50 miles an hour at a 30-degree angle, it's going across, right, at 25 root 3. I'm not sure what that is, about 40 point something, right? And it's going up at 25 miles an hour, you see? So it's going across at this, like 40, so it's going this way. If you were to track it horizontally, you'd go, it's going, 25 miles an hour this way, and it's going up at a rate of 25 root of 3 miles an hour this way, and 25 miles an hour that way. Yes? No? Maybe? Okay. Okay? Questions? No. All right. Then, so sometimes they want you to go backwards, okay? So it turns out when you're talking about direction angles that tangent of theta, if you have a vector in component form, so if, I should have written this first, but if V is equal to AI plus BJ, okay? Then tangent of theta is equal to B over A. Yes? Because that's like the y component over the x component, and you can find an angle by dividing B over A. But before you find theta, you have to know which quadrant you are. Okay? So for u equals 3i plus 3j, let's do negative 3j. Okay? That'll make it more interesting. Minus 3j, find the direction angle. Direction angle. Okay? And I could rewrite in trig form. Let's say rewrite in trig form. I'm going to call that trig form because I couldn't find in the book what it's called. In trig form. Okay? So direction angle, find the direction angle. So the direction angle, you know that tangent of theta is equal to negative 3 over 3. What's that equal to? Negative 1. So you know that that's equal to negative 1. So to find where tangent, you could look on your unit circle, where is tangent equal to negative 1? Second and fourth quadrant. But you have to be careful, right? Because you have to think about which quadrant you're in. So this says, from this point, I'm going to go over 3 and down 3. Which quadrant am I in? I'm in the fourth quadrant. So it helps to draw a picture. And then I would go around this way, and I would say that that angle is what? Inverse tangent. I would get 330 degrees. So you have to be careful because the inverse tangent of -1, if I plug that into your calculator, that's going to give you out negative 45 degrees, right? But the direction angle is defined as a positive rotation from the x-axis. So in this case, you have to call it not 330, sorry, 315, right? Sorry, everyone's looking at me. Positive 315, right? So if I put this in my calculator, I would get this, right? But since the direction angle is a positive rotation around the x-axis, you have to find the place where tangent is equal to -1. What if I had this? What if I had my vector -3i plus 3j? Then what would be my direction angle?
135.
Yeah, so that's where you have to be really careful, because if I did this and I took the inverse tangent again of -1, I'm going to get out my -45 again. But that, I have to know that in this case I'm in the second quadrant, and so that's, so in this case, my direction angle theta is equal to 135 degrees, right? So in this case, if you're going over 3 and down 3, then your direction angle is 315, but you're going back 3 and up 3, then your direction angle is 135. So you got to be careful. Okay? Then to write it in trig form, I need to find the magnitude. So the magnitude of u, okay, is going to be equal to the square root of this squared plus this squared. So it's the square root of 3 squared plus -3 squared, which is equal to the square root of 18, which can be written as, who knows how to simplify that? Geometry. 3 root 2, remember that from geometry? So this is 3 root 2. So if I wanted to put it in trig form, you put the magnitude in front. Trig form, yeah, I'm calling this trig form right here, okay? Trig form. And so if I want, or maybe it's called direction angle form. I'm not really sure. But if I wanted to write it in this form, I would put this is the magnitude. So this goes out in front, 3 root of 2, okay, times the cosine of 315 in the I direction plus the sine of 315 in the J direction. You get that? Done? Yeah? We're good, Ellen? Questions? Okay, now we get to look at some word problems.
Would you solve that further?
Would you simplify that?
No, because it's already in what do they call that? Linear combination form. So I mean, if they asked me to put this into linear combination form, then I'd simplify it first. But they say leave it in angle form in if they want you to put that in direction angle form, then you leave it like that. Okay? Okay? Because that way you can tell more about it. You ready to do some word problems? You're going to love these word problems. Okay? I have them somewhere on my PowerPoint. Here they are. So this is just from the book. This is an easy one. Find the component form of the vector. I did one like this. I don't think I even, well, let's do it anyway. Okay? So it says, I'm going to take a picture of it. Otherwise, I don't think I'll be able to write on top of it. Okay?
Are you still
What?
paused?
Am I still on pause? Did I pause?
Yeah.
No, I'm not paused.
At one point you paused.
I'm okay. Find the component form of the vector that represents the velocity of an airplane at a speed of 100 miles an hour at an angle of 30 degrees below the horizontal. Okay? So in this case, you got to be a little bit careful, okay? Because the reference angle is not just 30 degrees. The reference angle is 210, right? And you got to be careful because the reference angle determines whether the i's and j's are positive or negative, right? Okay? So in this case, it's just going to look, the magnitude is 100, right? So find the reference. So V we'll call it, is equal to 100 times the cosine of 30 in the what direction? Or that's wrong, okay? Cosine of 210, right? Cosine of 210 in the I direction, and plus sine of 210 in the j direction, right? And then you have to know what the cosine of 210, and if it's not an exact number, then you have to use your calculator, right? So it's 100. Who knows what cosine of 210 is? I'll give you a hint. Yes, negative root of 3 over 2 in the I, plus sine of 210 in the j, which is also negative, right? Negative 1/2 in the j direction. So in component form, it's going to look like negative 50 root of 3i minus, actually this is linear combination form, minus 50 in the j. If you left it like that, I'm fine. But what they want is this is called component form. Negative 50 root of 3, comma, negative 50, right?
So you can just turn it into that.
Yeah, because that's what this means, the same exact thing.
Okay.
Okay? So this is the horizontal component. This is the vertical component. This is called component form. This is called linear combination form. I guess this is called direction angle form up there. Okay?
So the i's and the j's are just saying where they are in the.
Yeah, I is meant to be the x direction, j is meant to be the y direction. Okay? Another word problem? Word. Can I go? Okay, go. Another word problem. Word. Boat. I stole this one from your book. So this is kind of a vector problem, and the way I used to teach this is breaking these two vectors into their horizontal and vertical components, and it gets super, super complicated. But there's an easy way to do this problem that's a lot easier than that, okay? So you have a force of 600 pounds required to pull a boat trailer up an incline ramp of 15 degrees, okay? So, and what they want to know is, this is kind of an interesting problem. If it takes you 15 pounds of force to pull this boat up the ramp, right? How much does the boat and the trailer weigh, all right? And one way you can do that is by this, since the amount it weighs is going straight down, right? So that's how much it weighs. That's one component. And the other component is pulling it this way. And since I could add two vectors, this vector is the sum of those two, and this vector is perpendicular to this plane. And it so happens, using some geometry, right? If I were to draw a straight line across this way, whoops, I want to align that. If I were to go this way, like this, I want to get it straight. And I were to go like this, I want to make it dotted too. Oh well, that's okay. Do you guys see that if this angle is 15 degrees, by corresponding angles, this angle would also be 15 degrees over? Oh, look at that, it's writing dotted. Do you understand that that would also be 15 degrees over there? Okay, so if this is 15 degrees and this is 15 degrees, you could do some geometry and you could figure out that what this angle is, which is 75 degrees. I should not make my lines dotted anymore, okay? So this angle will be 75, which makes this little angle 15, and this is perpendicular to this. So in order to find out how much the boat weighs, you just call, I'm going to redraw this triangle. Okay, so you have the triangle where this is going straight down. This is your force of 600. Oh, I messed up. I said 15 pounds. This is your force of 600 pounds going this way, right? Here's a 90-degree angle going this way, okay? 90-degree angle, and this is a 15-degree angle. And all you really have to do to find how much is going down is by doing right triangle trigonometry. Do you understand that? Okay. So the force going down is just, well, which trig function would I use? This is the what over the what? Where's that? What side is this? Opposite, adjacent, opposite, or hypotenuse? I'm looking at my 15 degree. That's hypotenuse. So, and this is the opposite from 15. So I could just say that the sine of 15 degrees is equal to the opposite side, 600, over x. And then I just do some simple algebra. X is equal to 600 over the sine of 15. And you divide 600 by the sine of 15. And you get that boat is being pushed, that boat weighs how much? 2,318 pounds. Do you get that?
Yep.
Okay. That's why you put things on rims to bring them up things, because it's easier, right? Do you get that, Lily? Sort of? Okay. I'm going to talk about one more type of problem, but I'm not going to solve it. Okay? There's one like this, and I don't want to talk the whole period. I'm just going to. You're probably going to struggle with this. There's a problem like this that is number 105, I think, on your homework. I just want to draw the picture for you. Okay? So if you had a problem like this, okay, it says a plane has set a bearing of 60 degrees south, 60 degrees east, which means that if here's my plane, and it's trying to go south, and this angle down here is 60 degrees, right? And it's going at 600 miles per hour. Okay? It says there is a wind blowing in the direction north, 45 degrees at east at 80 miles per hour. So that would be kind of like over here. Do you get that? Where this is 45 degrees right here, and this is 80 miles an hour. 80 mph. Okay? What they want you to do is add those two vectors together. Okay? So geometrically, what you can do, so you don't add vectors this, you have to add them tip to tail. So you take that red vector and put it over here, okay? And my resultant vector is going to be this green one going from there to there. You understand that?
Why is why?
Why? Because you always have vectors tip to tail, right? So the plane is trying to go this way.
Yeah.
The wind is blowing them this way,
Okay.
right? And so you're going to end up a little bit north of where he's trying to go.
Okay.
Yeah.
So the 80 mile per hour can also just be parallel down.
Can also, the 80 miles, yeah, it could also be here, but I want to show what it, yes, sir.
Couldn't you also just effectively them into X and Y?
Yeah, that's what they want you to do, okay? So what they want you to do algebraically, okay, is to take the first, so we'll call the first, there is a wind blowing, so we'll call it the airspeed, okay? No, that's not the airspeed. What's it called? It's called the, we'll call it like the airspeed, or the plane speed. Plane speed, okay, is going to be given by 600, you have to be careful with this, cosine of, if this angle is 60 degrees, what's the direction angle? How many degrees is it from here to here? How many degrees is this? Plus 60 more makes 330. Okay, so you have 600 cosine 330 in the J, plus 600 sine of 330 in the I. In the I, and 330 in the J. Okay? This one is just 80 mile an hour wind, right? 80 miles an hour, and that's 45 cosine of 45 in the I, okay? Plus sine of 45 in the j. All right? When you add these two vectors together, you add their I components and you add their j components, and that would give you your resultant vector. Yes, ma'am?
But I have like root 2 on one of them, so it's like.
Yeah, just, I think is it, yeah, you're gonna have to plug it into a calculator.
Oh, so you plug the root 2.
Yeah,
into
yeah.
the-
So the resultant vector, okay, so this is the wind vector, this is the plane vector, and I think the actual airspeed vector is gonna look like this. 600 cosine 330 in the I direction, plus 80 cosine of 45, right? Also in the I direction. So you add up the I parts plus, right, 600 sine of 330 in the j direction plus 645 what?
It'd be 80 sine 45.
Sorry, 80. Let me clean that up. Okay, 80. Well, 80. 80 sine of 45 in the j direction. Okay, and so you plug this in your. I would just plug this in your calculator. You get some number in the I direction, and you get some number in the j direction, and that would be your resultant vector. Then they ask you to find the magnitude of that resultant vector. You take those numbers, you square them, and you take the square root of them. Okay? And then it asks you to find the direction of the resultant vector, and you would have to take the j part, divide it by the I part, take the inverse cosine of that, that would give, or the inverse tangent of that, that would give you that angle right there. And then you need to subtract from 360 to find the angle to here. You follow that?
Wait, so the direction of the plane is the angle of the ending, like the end.
Okay, so if I want to find the airspeed, right, I add up my I parts, I add up my j parts. That's going to give me some vector. Okay? To find the speed, right, that the plane's actually going, I'm going to take the square root of something I squared plus the square root of something j squared, right? Understand that? To find the direction, so this is vertical component, horizontal component. To find, I know that inverse tangent of, we'll call this B, we'll call this A. Inverse tangent of B over A is going to give me this angle right there.
Okay, I just want to
Okay.
make sure that the angles, how you found
But I want the direction angle, so I guess that would be there. Or I guess if you subtracted this from 90, you could find a bearing, right? If you knew, say this comes out to be 37 degrees, right? You could write this as the bearing is 53 degrees, or south 53 degrees east. You understand that? The resultant speed and direction, you'd have to say that from south it's so many degrees. There is, you guys, I got to tell you, there's one more problem. I will probably go over it. I'll end up going over it on Monday. Okay, it's this kind of problem, which is a static equilibrium problem. So the force on here plus the force on here is equal to 0, and the force going straight down. And all the horizontal forces, what ends up happening is this force plus this force plus this force have to all add up to 0, right? F1 plus F2 plus F3. F3, this is F3 going straight down, okay? Those three forces have to equal to 0 because it's not moving anywhere, right?
So you
And
can find the magnitude of
yeah, and then F1 has to be equal to F2 because it's not moving side. It's not F1 is equal to horizontal component of F1 and the horizontal component of F2 have to be equal. And the vertical component of F1 and the vertical component of F2 have to be equal to 2,000. See that? Yeah, F1 plus F2. Well, they're in the opposite direction.
Yeah, F1 and F2 are going up,
But-
F2 is going down.
So these problems are really hard. Look in the book, see if you can figure it out. I will probably go over the one like this on Monday because I know people are going to have questions about that. Okay?